Welcome to Digital Toolbox. Today we're going to create jigsaw joints, and as I go through this tutorial you guys will have some questions, but hopefully I'll answer them all. And we're going to get started by creating a new file. And I'm going to go to geometry and grab a curve button, and then I'm going to set one curve to a line. Then I'm going to go to curve, go to analysis, and find the endpoints. And I also need the distance between these two endpoints, so I'm going to point and grab distance. And the reason why we need this is you'll see as I go to logic and grab a 3-variable expression, and I'll edit this expression in the expression editor, and it's going to be open parentheses twice x divided by 2 close parentheses plus y plus z close parentheses divided by x, and hit OK. I also need two of these. One will be positive y positive z, and the other one will be minus y minus z. And then I also need to grab two sliders, but I'll just take one, edit this from floating points to integers, upper limit of 12, and I'm going to set the value to be 4. I'm going to copy and paste this, go back to logic and grab a 1-variable expression, and I'm going to put this as x over 12. So I'm going to convert the inputs of the sliders into inches. Then this will go into y, and one will go into z, and I'll explain them as I finish up this little session right here. So next we're going to go to curve, go to analysis, and grab the evaluate length, and I need two, one for each resultant. And I'm going to just drag this curve over here, and I'm going to put the curve into C. So now as you can see that if I move these sliders, the points are driven further apart, and which will dictate where the circles will be, and which will dictate how wide the joint will be. And also with this slider, which is the length of how far the joint we want to have. The slider on top will eventually become the radius of the joint. So I'll put both at 3 right now. And then the next thing we need to do is to create circles. So I'm going to grab primitive, go to primitive in the curve and grab the circle button. And I'm going to need 4 of these. So these two will go into here, and then we'll take the radius of circles and we'll put them in here. And then I'm going to go to logic and grab another 1-variable expression, and I'm going to put this as x times 2. Commit, and these will be the radius of these. I'm going to put the circle radius into there. And the points where these two circles that end here will be the endpoints and starting points of the line. So eventually we will double these circles out here, and then from these endpoints we're going to create our S curves from the two circles that we will eventually create, and then connect the two lines, and then eventually be our joint. So then the next thing we need to do is find the intersection points between the line that we input in Grasshopper and the intersection points between the circle and the line. So to do that, we're going to go to intersect, go to physical, and grab the curve. We're going to need 4 of these because we have 4 circles that we want to find intersection points to. So C of every circle will go into B, and then the curve will go into A. So you can see if it's finding the intersection points. And then we need to rotate these points so that it's 90 degrees over, so the points are on top of the circles relative to the line. So to do that, we're going to go to X form, go to Euclidean, and grab the rotate. And we're going to need 4 of these as well. And then we're going to go to parameters and grab the number, and I'm going to name the number as 90 degrees and then set the number at 90. I'm going to go in the expression editor, and I'm going to just type in rad open parentheses a close parentheses, and just to make it easier I'm going to delete these 3 here, and I'm going to copy this again because I don't want to retype in rad a, and I'm going to put these into the angle, And then the geometry will be the points that we want to rotate. Whoops. And then the points where we want to rotate around, or the rotation plane, will be from the evaluative points. And then the bottom two circles would be based on the starting point and the end point. So now you can see that the two end circles, one is rotating to the left and the other one is rotating to the right. So to make it the same, we're going to take the bottom one, and instead of positive A, we're going to put in negative A. So now they're rotating on the same, well, having the points on the same side of the line. So I'm going to unpreview these intersection points. And I'm going to unpreview the evaluative. I'm going to unpreview the endpoints. So now we have our rotation points. And then from these points, I'm going to create two more circles. So these two, the first two rotations. So I'm going to go back to curve, go back to perimeter, primitive, and then grab circle. Two of them. And then use the original radius. So now you can see that if I made a line from here to here and then create an S curve and then connect that and then reverse the S curve and then bring it back to this point, we've created our joint. So I'm going to unpreview the first two rotate and these circles. And then what we can do now is to find, or the next tutorial we'll do is trying to find the using these endpoints at the circles, and then using a point on the circle by using a value of length, we can create arcs, and then from that we'll create 4 arcs based on these circles, and then it will connect the lines to create our joint. So continue to the next tutorial, and thanks for watching.